Welcome back to Tech CJay's video notebook. You've made it to part 5 of our DOL motor control basic series. This episode is where things really come alive. We're now dealing with interlocks, reversing starters, selector switches, and limit switches. These are real-world, industry-grade techniques used in automation systems to ensure safe, reliable, and controlled motor operations. So let's gear up, stay focused, and take your understanding to the next level. Here's our updated Direct Online, or DOL, motor starter circuit. You'll see that it still begins with a 3-phase power supply feeding through a circuit breaker. This acts as our main protection device. From here, the power lines split and connect to 2 magnetic contactors, S1, which will serve as our forward contactor, and S2, which will handle reverse operation. Both contactors then join back together into a common overload relay, which is wired in series before reaching our 3-phase electric motor. On the front of both contactors, S1 and S2, you'll notice 2 terminals labeled A1 and A2. These are the coil terminals. When we apply a control signal voltage across A1 and A2, the contactor energizes, allowing power to flow through to the motor. In the upcoming slides, whenever we reference S1 or S2 output, remember that we're referring to these 2 contactors, each with its own coil and function. S1 controls forward rotation, and S2 controls reverse rotation, all depending on how we design the control logic in the next circuits. The control circuit shown uses electrical interlocking to prevent 2 motors from running at the same time. Each motor starter, S1 and S2, has a normally closed auxiliary contact wired into the other's control circuit. When one contactor energizes, it opens the inhibit contact in the other's rung, blocking it from starting. This ensures only one motor runs at a time, providing a safe and reliable mutual lockout method. This control circuit introduces the use of a 2-position, 2-circuit selector switch to interlock 2 motors. The logic here is simple but critical. Only one motor can operate at a time. The selector switch determines which control circuit is energized, either motor 1 or motor 2, but not both. This method is ideal in systems where 2 motors share a mechanical load or must never run together for safety or operational reasons. Now in this control circuit, we're working with a reversing motor starter for a single motor. 2 contactors, S1 for forward and S2 for reverse, control the motor direction. Electrical interlocks are achieved using normally closed contact from each contactor to inhibit the other. If S1 is energized, it prevents S2 from turning on, and vice versa. The stop button here is shared across both contactor circuits, acting as a master stop for safety. This prevents catastrophic damage if both coils accidentally activate simultaneously. This control circuit builds on the previous design by adding timing relays to delay the reversal of motor direction. This is used in high-inertia systems where immediate reversal could harm the motor or mechanical system. When a change in direction is requested, the timing relay introduces a programmed delay before energizing the opposite contactor. This ensures the motor has time to decelerate or stop completely before reversing, a vital safety mechanism in cranes, conveyors, or flywheel-driven machinery. This control circuit takes a different approach to motor reversal by integrating a selector switch. The selector switch determines whether the motor runs forward or in reverse, but a single start button is used for both modes. Electrical interlocks still prevent both contactors from engaging at the same time. This type of control is very user-friendly and suitable for applications where operators must choose direction before initiating motion with a single action. The control circuit shown introduces travel limit switches, a safety feature that's crucial for applications like hoists, trolleys, or gantry cranes. Here, the forward and reverse contactors are electrically interlocked as before, but each has its own travel limit switch. If the motor reaches the physical endpoint in either direction, the corresponding limit switch opens, preventing further motion in that direction while still allowing reverse operation. This protects the system from overtravel and mechanical damage, ensuring controlled and confined movement. That wraps up part 5 of our DOL motor control basic series. We've now covered motor interlocking, reversal control, time delay logic, and limit switch safety. These are foundational building blocks used in industrial automation and motor protection. In part 6, we'll explore advanced control combinations, including automatic restart logic, multi-speed motor starters, and safety relay integration. If you're learning something valuable, please support the channel by clicking like, dropping a comment, and hitting that subscribe button. Thanks for watching. Stay tuned for more on CJay's Video Notebook.